This is Mark Escourt, one of the members of the IAFSM board. I'd like to introduce William Henningsen to today's broadcast. He's going to be giving a detailed presentation on the use of DotProduct handheld scanners. And just to give you a little bit of a background on William, he's currently the acting manager for forensic investigations for the Omaha Police Department, and he's been doing that for 21 years. He's a certified forensics video technician for Leica. He's previously worked on the IAI and is certified as a crime scene analyst. He's an IntelliCAD user and he's been doing that since 2007, and laser scanning since 2013, and has done around over 300 crime scenes in that time. He's acquired the DotProduct scanner recently, well, in 2016, and it looks like he's been using it quite extensively, and you'll see that from some of the case studies he's got. And he's got extensive experience in crime scene investigation, forensic video analysis, and forensic mapping. He's recently become a member of the IAFSM as well. He's a board member, and is also a member of the PSFM, which is also a forensic organisation. Okay, this is going to be recorded, so if you know people who wanted to attend but couldn't, this will be shared probably on YouTube, so you can send them a link to that. And if you have any questions, please add them to the questions box in the bottom right-hand corner of your GoToWebinar control panel, or add some notes in there for us. We'll go through those at the end of the webinar. So, without further ado, I'll hand over to William, and there you go.
Okay, thank you, Mark. I appreciate that. Good morning, everybody. Thank you for coming to the webinar. And first, I want to let everybody know I'll do everything in my power to keep from interrupting today, but I do manage a working lab, and we do crime scene investigation responses. Hopefully, nothing will happen during the presentation, but if I have to leave, that's going to be the reason. What I was asked to do was present our methods for integrating DotProduct's DPI-8 scanner into our workflow. And like Mark said, we acquired this scanner in 2016, January of 2016. A lot of the cases that we've used it for have not been adjudicated yet, and so we're kind of limited on what we can show at the moment, but I do think we have some important cases that we can illustrate. In fact, a case that we assisted another agency in the use of the DPI-8, and we also are in the service of, or in the process of becoming an ISO 17020 accredited lab. Part of that is that newly adopted instruments, newly adopted equipment has to be validated and recommended for use based on the results of that validation. We went through a validation test and reporting process for the DPI-8, and I wanted to talk about that specifically today. Just as an introduction, this is my information here. It's pretty much what Mark covered from the start. I've been an IAFSM member since 2014, I believe, and just recently became a board member, and I'm really happy to be more involved in the organization right now. I think it's headed in a good direction at the moment. As far as DotProduct goes, Tom Greaves was very instrumental in his presentation at the first IAFSM conference in our adoption of this technology. He gave a pretty powerful presentation. It's pretty obvious to me at the moment that it was a unique product in this area and in this field, in that it was very small, standalone piece of technology, and very affordable. So I would characterize this company as 3D innovators. It's a privately held company, and these are the principles of the company, but our purchase is primarily based upon Tom Greaves' presentation that I saw at IAFSM during their first international conference. When we were looking at the adoption of the DPI-8, it came out of some issues that we were seeing with our tripod scanners, and I think this is pretty common to a lot of tripod scanners. Our current equipment is a Leica ScanStation C10. We are looking to upgrade that, but most tripod scanners are going to exhibit the same kind of problems in that they are tripod mounted, and there are some gaps in data capture because of that. They can't see underneath themselves. Oftentimes they're very difficult to fit into small spaces like drawers, closets. You know, they can be inverted now, but hanging those inversions can be difficult to rig in small spaces. There are also significant costs associated with tripod scanners. When we were noticing these gaps in coverage, we looked at other smaller tripod scanners, maybe even some that were manufactured by other folks, and there was nothing below the $30,000 mark that we could find. The other issue was upgradability of tripod scanners is pretty much lacking. I don't know of too many other than Leica that will upgrade their units to have more capability. So we were looking for something to supplement our tripod scans. What's good about what we currently had and what we didn't want to lose is that our scan station is very accurate, and we have the ability to introduce NIST traceable reference artifacts into the scans. We can verify on every single scene, and we do validate on every single scene that our instrument's operating properly, and that's an in-field on-site measurement, which is very important to us. It also has an incredible range capability. I wouldn't call this true usable range, but it does have a 300-meter capability at 90% reflectivity. Your usable range is more in the range of 130 to 150 meters. You're getting good usable data off of dark gray surfaces at those distances. It's also typical for most of these tripod scans and for 3D measurement in general that these are large data sets. So that was an issue. The distribution of those data sets can be a little bit complicated. One thing we also like is that about our current equipment was that Cyclone is a pretty powerful piece of software, and it allows us to do registrations and to develop pretty compelling deliverables, but that's all done in the lab. And so it's all after the fact, involves some post-processing that takes time and extra personnel. So when I saw DotProduct, when Tom Greaves first presented it, it's checked off a lot of these issues that we were having. It's mobile. It allows us to walk around our objects. It's really simple to use. In fact, I think we could probably train our secretary to use it. It's handheld. It's untethered. I don't have a tripod, and it's incredibly inexpensive. Our whole package cost us less than $5,000. As you're going to see here with our validation study, it's engineering grade data, and we validated that fact. It's also real-time capture. Now, while you can see preview screens in most traditional tripod scanners, and ZNF notably has made some improvements on that and enabled them to do on-site registrations and viewing of their scans. DotProduct was probably the industry leader on this. You could see the full scan on the tablet at the scene. It's really light as far as computing power required. It's small data, and it's highly compatible with a lot of other software packages. One thing that I think is not emphasized a lot about this technology or this particular product is that it's easy to repair and it's upgradable. It's a really modular unit with existing technology used alongside DotProduct software. If I damage the tablet, it's really simple for me to replace it. It's a $200 to $300 cost for me to just put a new tablet in, load up the proper calibration file, and then I'm back in action. If a new sensor becomes available, I can send it back to DotProduct and have a sensor attached to this system. There have been a lot of advertised upgradable or modular laser scanning systems that really turned out to be vaporware. I can think of a few offhand that we looked at when we were first acquiring a laser scanner. A lot of those things were never brought to market. This, I think, is a fully realized modular scanning system that is useful to people in public safety because we just don't have huge budgets. This is an example of, not inclusive, but an example of some of the integration partners with DotProduct. So you can see that there's pretty wide compatibility for this product. When we were looking to acquire it, this particular case was one of the things that we looked at as far as determining whether or not this is usable technology. It was the renovation of Longfellow Bridge by Sokkia Corporation. In this project, they were tasked with replacing a lot of steel plates used to link different parts of the bridge together. I believe they were using hand measurements and maybe some other machine measurements on site, but it was time consuming, it's a difficult measurement environment, and our questions as far as whether or not we were going to adopt this technology were, is it accurate? Is it reproducible? Is it precise? The other concerns we had were, DotProduct is a pretty new company. How innovative are they? How stable is the company? And this was a good case example, gave us some information as to whether or not this was an adoptable piece of equipment for us. During this process, you can see the guy on this slide here is holding an extension kit that I believe DotProduct developed for this project in particular. What he's looking at is the tablet version, or the tablet portion of the instrument. At the other end is the sensor, but it was developed so that these guys doing the measurements on scene were not going to have to rope off at elevation or put themselves in a dangerous situation in order to capture the measurements that they need. And when they ended up doing a study on it, they actually determined that this was not only a faster method of measurement, but it was indeed more accurate than their traditional methods. So this is a picture of the sensor portion of the scanner up above. And you can get some idea here of how difficult it would be to get a person in position to do that. We're either going to have a platform or a lifting device or somebody roped off and hanging from high steel in order to get these measurements. That's another overall picture of it, again giving you an idea, analogous to a lot of crime scenes, not an easy environment to work in. And then that's the instrument itself put together. Sokkia did some examinations of their traditional measurement methods versus the DotProduct measurements, and you can see from this tablet, or from this table here, that they found they were more accurate and their speed of capture was faster, and so the whole project ended up costing them less. From a crime scene investigation perspective, this is important to us because we want to get actionable information and evidence out to people as fast as possible. This is an objective study that shows us that that's possible, or that there's something to be gained for us in a crime scene investigation perspective. So our proposed uses for it, after we decided we were going to adopt it, was that it was going to be a contextual and supplemental scanning device for our tripod scanner at major case scenes or more complex crime scene investigations, that we would probably end up using it for field measurements at smaller crime scenes or at crime scenes that were of lesser order importance. What I mean by that is questionable death investigations or smaller shooting scenes. What looked like it was a powerful tool with regard to this instrument was that it allowed us to do quick distribution of 3D data sets. If I remember properly, DotProduct claims 50 times lossless compression, maybe even 100 times lossless compression on their data sets, which is pretty impressive. I don't know of anybody else whose data sets can be emailed or texted. That kind of stuff is just unusual in this field. So we can get this stuff out to people very quickly, whether by physical transfer on a disk, or we can even email it if you've got a Wi-Fi connection or some kind of wired internet connection. The one thing we have not fully realized, but was one of our proposed uses, and I don't see any reason why it couldn't work, is crash reconstruction, specifically measuring crush on accident vehicles. So we went with this solution, and this is the version that we bought, the DPI-8. It's a sensor, Carmine PrimeSense sensor on the front, attached to a tablet. The Phi3D software is the actual measurement or processing software inside the tablet. All the processing is done on the tablet. There's no tethering to another device. There's nothing holding you up while you're trying to do these data captures. And no other software to buy, really. If you wanted to do standalone measurement with this device, it could be done. And what's nice about DotProduct is they now have a Dot3D app, which is a viewer type. It can be either fully licensed or it can be used as a viewer of their native scans. It can also save out their native scans into universal formats like PTS, PTX, etc. But that is how we can deliver these to our customers, which are crime scene investigators, which are detectives, which are prosecutors and defense attorneys. We can get this stuff out to the trier of fact quickly, the investigator quickly, in a format that doesn't cost them anything extra. They don't have to buy extra software. It does, in fully licensed version, give us the ability to edit the point clouds, to save annotations into the point cloud, so we can do that up front and give them a finished product that they can view for free very easily on their mobile device or on their Android mobile device or on any PC. The newer version of the DPI-8 is the X, and I really like this. I saw this housing first at the last IAFSM conference and was really impressed by it. So again, illustrating that it's modular and upgradable, we are going to send our unit back to be upgraded to this new armored housing, which still gives you the ability to use one-handed. You can see that there are D-rings on each side of the unit. That's fully enclosed now, but now I can put a neck lanyard on it so that in environments where I'm not worried about hanging myself up, I can let it drop and hang at my waist when I'm working on other things. But still easy to remove the tablet. If you look at the top of this section here, all I have to do is fold that tab to the side, and then I can remove the tablet to use for other applications or for data transfer. On the front of the unit, we have rubber mounted bounce pads. So, you know, one of the things this unit is sensitive to is jarring, and so that's protective. The fact that it's a hard armor around the outside is important to me from a crime scene perspective. We're not always working in nice environments, and it's flat-footed so that I can set it down and not have to worry about it falling over or damaging the equipment. So we are probably going to upgrade to this as soon as possible. The next thing I want to talk about is our validation study. And anybody who's going through the accreditation process or who's been accredited will recognize this process. When you adopt new technology, you've got to prove that it's fit for purpose before you recommend its use, and that's what we did here. One of the things that was really helpful to us in this case was the Brunson AccuScale-DP Kit. This is a kit that's developed through a collaboration of Brunson Instruments and DotProduct to give their point clouds a couple different things. One being a calibration scale bar routine, which tightens the precision and accuracy of the cloud, and to also give you a reference measurement artifact within the cloud. It comes with 6 bars, which can be assembled in pretty much any configuration, even vertical. So you can have everything from a 6-meter bar to 3 2-meter bars. You are limited to 3 bars because the April tags here that you see across the center of that image, there's only 3 sets of them, and they're all color-coded. You have 2 green, 2 blue, and 2 red. In essence, replicating a UCS that you would see in some kind of point cloud software. The other really cool thing about it is they give you a NIST traceable thermometer with that kit. Now this scale kit itself is not NIST traceable. It's assembled in an ISO 9001 compatible facility, and during the construction process, confirmed this with Brunson, that it's compared against NIST traceable references during the manufacture. But one thing that gives it even a little bit more validity than NIST traceable devices, if you want to really get into it, is it's calibrated across a wide range of temperatures. So any variable temperature that affects the length of those rods is accounted for during the scan process by entry from this NIST traceable thermometer, which I think is pretty important. But you can assemble these kits, put them out into your scene. They're automatically recognized by the Phi 3D software. These April tags are automatically read and recognized as Brunson AccuScale rods, which are 2.2 meters long. That's added into your scan as a known reference artifact and as a calibrating device. So here's a video of that kit being put together. We've got some studs that link the rods themselves together in whatever configuration you choose. And this is not me in this video. I think this is Chris Ahern from DotProduct, actually. So we just attach the April tags to the end of these bars. This process is basically an extension of a recommended best practice by DotProduct. When we first acquired the device, their recommended best practice was a scale bar targeting or introduction of known measurements through total station or some other method into the scans. You can see here this one bar is unique in that it can have a foot attached to the bottom of it, and it can stand vertically to give you your Z-axis in the scene. But getting back to what I was talking about, it was recommended that you use April tags or checkerboard targets at known distances inside your scan to give that calibration of the overall scan to improve accuracy. And so here's a typical 3-bar setup within a scan. There's a 2-bar setup, and then I think they're going to show a 6-meter bar, 1 tag at each end. So you can put this in a lot of different configurations depending on how big your scene is. And when you go to use it, for those of you who haven't seen the scan operated, you're actually going to enter this temperature when you do the optimization on your cloud. The scanner itself operates much like a video camera. We move across the scene, you see it automatically recognizing those April tags by turning them red, blue, and green. Those are used to register the frames between the video, and they're used to calibrate, and they're used as a reference artifact. So really kind of a neat integration of reference artifacts into the on-scene capture, really similar to what we do with our Leica scanner. So there you see you've got an environmental temperature. It's recognizing those bars at 2.2 meters, and then it will automatically calibrate based on what you've given it with this AccuScale kit. And while the scanning process was sped up there, this is pretty much how fast it does optimization and post-processing. So pretty quickly you've got a finished result that's well calibrated, tied to reference artifacts in your scene. So that in and of itself is an important thing to us from a forensic standpoint. The study we chose to do, we wanted to conduct under conditions that were deliberately difficult. Any kind of video tracking device is going to have difficulty in an environment where you have photo gray background, where there's very little pattern on the floor or on the walls or on the ceiling. We are interested in how this device will operate in realistic conditions, and so we gave it some difficult stuff. The one concession we made was a couple different April tags put there in the corner. But as you can see, this is a photo gray background with not a lot of pattern in it. There's some geometry to the scene which is required for structured light. This is a near infrared structured light device. We've got to have some kind of relief in the objects that we're measuring in order to get accurate representation of it. So we did choose a corner, but other than that, this is not an easy environment for structured light scanners. What we used as a baseline measurement here was our Leica C10 scanner, which has already been adopted by our lab. We chose to use 2 of the AccuScale bars here, and the 3rd bar you see there that's red with blue and white targets at each end is our own NIST traceable Leica twin target pole. And we know that pole is 1.7 meters as traceable to NIST, and what's key here for the concept of the validation and study is that known measurement stands outside of any calibration that's going on in Phi3D related to the AccuScale bars. And so we have an external validation as well as an internal validation of the accuracy of this instrument. The other part that's key here is that we chose to avoid in the measurements the use of computer-aided center location in targets. Now I understand, when you're capturing trajectory rods and things of that nature, you're going to do high resolution scans of them. Typically what we would do with our Leica scanner is we would get a high resolution target capture on that NIST pole and let Cyclone find center and let the internal scanner software find center on the target. But what we're curious about here, and what I think is more accurate as a validation, are situations where we have to measure objects that we did not know at the scene were crucial to us, and that happens commonly. If you do enough crime scene investigations, and we've done a fair amount, we're approaching 400 crime scenes scanned now, you will find things in your scene that have to be measured that weren't necessarily captured at high resolution, and you don't have the option of finding a computer, having the computer assist you in finding the limits of that measurement. So we took 3 different operators. We did 3 different scans here. We did a Leica C10 scan of the area, the validation study area, and then we did 2 separate DotProduct scans of the area by 2 separate operators. We then brought all of that information into Cyclone. We had 3 different people take measurements, and these are user-chosen pics of the measurements of that Leica NIST pole within Cyclone. And we're going to compare that to the NIST stated length of that pole. The scanner resolution that we use for the C10, again, not a high resolution scan. This is what I would call probably a medium scan. These are the settings that we used. So we're looking at point spacing of 0.085 feet at 100 feet for this particular scan for the validation study. Again, not making ideal conditions. So these are the results of it. We got screen captures of the measurements that we made within Cyclone. On the left, you see 2 different pics from the C10 scanner. So here's one C10 scan cropped out, and we've got a distance of 1.702 meters on that pole that should be 1.700. We've got a second person measuring here, the C10 data. They're coming out at 1.705 on user pics for that measurement. And then these 4 are separate scans made by the DotProduct scanner, and you can see we're comparable here. We're at 1.704, 1.705, 1.705, and 1.706 on DotProduct scans compared to the Leica C10 scanner. The other thing I will say is that we mapped out on the floor distances that we were operating within when we did this DotProduct scan. We noted that DotProduct recommends the best ranges for this instrument. We don't have the short range. We have the normal DotProduct scanner is 3 to 8 feet. So we operated in a range of 3 to 9 feet for our DotProduct scans. The Leica C10 scanner was a little bit further back at 12 feet. All those distances were confirmed with a Leica Disto. But again, we are comparable in measurement here. And then when we go to do the math and the report on it, not that it's complicated, but just so you can see, we're looking at accuracies that are at or above the expected accuracy for DotProduct, and entirely comparable and really what we would expect. It meets our expectations for accuracy and reproducibility. So in the Leica scan station, we are 99.8 to 99.7% accurate on user pics within that cloud. Todd was one of the operators that we used for user pics on the DotProduct scans. We're at 99.7 and 99.76 for his measurement and mine. And for the second scan, we're at 1.706, 1.705, so 99.6 and 99.7% accurate again. I think in DotProduct stated literature, it's you should be seeing results from anywhere from 99.8 to 98.8% accuracy. We're well above that here. So this definitely met our expectations, and we were able to recommend it as an instrument during our ISO accreditation. The last thing I want to show is a couple different pieces of data and workflow that we've got from DotProduct and how we've integrated it with other things. This particular example comes from a scene that we assisted another agency. What we wanted to do here was do comparison of gross measurements, again user pics, within Cyclone on clouds that were developed between tripod scanner, in this case a P30, and DotProduct scanner. We wanted to assist this agency quickly and give their command staff something that they could use in briefings or in press releases or in news conferences. And so the DotProduct scanner was really useful to us in that case. I'll show you and give you some more details on it later, but of this particular vehicle we did laser scans with tripod scanner all the way around, and then we produced a data set of DotProduct scans that was exterior and interior to the vehicle all in a single scan. Now that again pushes the limits of what DotProduct recommends you should do. We were approaching a 10-minute capture there, and they say that can be problematic. In this case, I think you'll see that it was not an issue, and we can externally validate that. So the wheelbase on this vehicle with tripod scanner is 8 feet 10.1 inches, and then when we do the DotProduct scan, which I'll say again was kind of at the limits of what they recommend, our measurement is 8 feet 10.0 inches. And we took a couple different measurements here just to get a range, and this is about the median range of the variance that we got. Some of them went down to 8 feet 9.9 inches, some of them went up to 10.3 inches. But this is about in the middle of what we expected and what we found from different users picking the wheelbase length on this particular vehicle from this incident. We did use the previous scale bar targeting method. If you watch the spotlight down at the bottom here, you can see a scale checkerboard target, and over here is another scale checkerboard target. We only introduced 2 of them, one set into this case on the x-axis. And I think we got pretty acceptable accuracy. It was much easier to capture the interior of this vehicle with the handheld scanner. If we were forced to do that with a tripod scanner, it would have been a lot of different scans and a lot more time invested. The important thing here is that I think you recognize you can use this as a standalone measurement device. So this is a video kind of illustrating the scene that this came from. The scene itself is unique in that we were scanning and doing 3D data capture on the scene 3 days after the original incident. There was a scanning process or a total station capture process with a Sokkia total station on the day of the incident, which gives us point-to-point measurements and some survey control that we can tie everything else to, including position of the vehicle that we just looked at. We then did tripod scans of the scene itself, tripod scans of the vehicle in this agency's garage, and then DotProduct scans of the vehicle in the agency's garage. And just for kicks and to see how it would work out, we did a comparison on the integration using the tripod scans from the vehicle and then the tripod scans from the DotProduct scanner. And there was no appreciable difference. The vehicle marks that were made on the ground and the total station data that was collected lined right up with the wheelbase of this vehicle. So again, no appreciable difference in an appropriate circumstance for the use of this scanner. Now, you will never scan a scene like this with a handheld scanner entirely, but it definitely plays a role in getting information out quickly, verification that you have your data captured on site without question, and in the ability to transmit this data to other people. So the only reason we show this is just to demonstrate again that DotProduct data integrates really well and precisely with multiple sensors and data from multiple sources. This is another case example. In this instance, it's a questionable death investigation that takes place in a bathroom inside a house. Now, there's a lot more data collected here, but we kind of narrowed it down to just the important part that integrates with DotProduct. The tripod scanner that it integrates with in this case is a C10 scanner, and there's some difficulty here in reaching areas of the scene that were critical to our investigation, turned out later to be critical to our investigation. This is a walk-in tub. You can see there's an individual in the tub that's a pretty substantial size. She's been in the tub for a considerable amount of time, and it's a difficult area to get to on the opposite side of this tub wall. our laser scanner had some real difficulty getting in there. We'll look at some stills of this later, but you can kind of see the data line there, those light-colored points across this individual's face is the gap or the seam between DotProduct data and C10 data. So like I said, this is a small environment, a lot of geometry, definitely good for DotProduct, but it's a walk-in tub, it's tough to get to. You've got occluded areas behind that bathtub wall, at the water line, and behind the curtain. And hanging a scanner from the ceiling in this case was just not an option. Now if you could erect a tripod over the top of the tub, but that gets into all kinds of scene contamination issues, which we didn't want. And the handheld scanner really did us a favor here in this questionable death investigation, and you'll see why in a moment. This is a perspective from the scanner, so you can see we've got some difficulty making a full capture here. This individual had invested a lot of time and effort in making this appear as though it was a serial murder. She'd paid attention to the news media enough in Omaha to hit some real hot button issues with our investigators, and we ended up spending a couple days on this scene trying to determine whether or not it was a questionable death or whether it was a homicide or a suicide. Our ultimate conclusion was that it was a suicide, but our handheld scans were integral in making that consideration. You can see here that we're not getting a lot of access to things that are directly behind that tub wall, but once we integrate with the DotProduct scanner, I'll point this out again, the data integration line is right along these lighter colored pixels. You're getting the water line now, and there's void area in particular, what appears to be a void area there in the scans turned out to be really important to us later. As we investigate this scene, things changed, and that void just became clear water line. But when we examine it from the side, so this is just go back one, we're looking at this void from above in this image. And we go to the right, when we go to the next slide, we're looking at a profile view of what that void appeared to be from the top. And I hope this comes across with everybody's bandwidth and the connection, but you can see this ramped section of pixels here, or points. That was actually the butt of a revolver. This individual was wearing gloves, but it was not immediately apparent that she was shot or what the mode of death was. When we look at the scans, we find the revolver in the water, we can see that it was there next to her, and that helped our investigators make a determination on whether or not this was a suicide or a homicide. And without that data, it would have been a lot more difficult for us. So DotProduct was really useful to us there. And then here's a couple other examples of integration of tripod scans and DotProduct scans. This is my own basement, our rec room. We've got a P30 scanner there integrated with DotProduct data, and when we look at it, the colored data in this case is DotProduct scan, and the intensity value data there is from the tripod scanner. So integrated really well. And again, we use the scale bar targeting method, which I think would be much easier with the AccuScale kit. So that's another consideration for us on a purchase in the future. If the bandwidth will take it, I just wanted to do a quick .3D live demo so that folks can get some impression of how that can be used to distribute their data and make deliverables for folks. So this is when it initially came out, we were using it in beta form, but it's fully developed now. And as I mentioned earlier, you can have the licensed version, which comes with your scanner if you buy a scanner, or this can be freely distributed in viewer version for your end users to view the scans. As long as they have access to email or some kind of data delivery, they can open this up on their mobile device or on their PC. So in this case, we're going to look at the scan that I did of our rec room in the basement. just show you some tools that we have in here. Pretty easy to navigate. You're not going to spend a lot of time teaching folks how to see or how to use this, this viewer. If I hold down on the wheel, I can pan. If I roll the wheel, I can zoom. And then I have these tools up above for measurement, edit, and annotation. Now the viewer version, I believe, only has measure. You would have to do the annotations and the editing if you chose to do it in this format on a licensed version. But the deliverable that goes out to viewer version can be measured by the end user. So I'll just show you how this measurement works. We just long press. It gives me a movable end, and then long press to get the other end. I really like this feature that this end can be moved to different locations if I choose to measure, or if I've missed the pick on the start. It is sensitive to the data capture that you used in the beginning, so you've got to be careful of that. I can also annotate this through a long press. And when I go to save this cloud now in the licensed version, that annotation goes along with it. And so any evidence that I want to point out, any particular observations that I've made in the 3D cloud go along with this cloud whenever I save it and distribute it. And then I have a kind of a rudimentary edit feature, which is nice in a light piece of software like this, that I can use to crop pieces of the cloud out or cull noise from the cloud. So let's say I want to take this piece of furniture out. Again, got movable grips. I can choose the method and then crop out. So now I've cleaned that portion of the cloud out. What I'm curious to see with this, and what we haven't had time to test yet, is whether or not we can take advantage of this tool and the compression of the .dp files, which is native to DotProduct, when we bring in PTSs and PTXs from other clouds. So I'm going to be talking to Tom Greaves and Chris Ahern about the viability of that. But if that compression, there are other tools out there. Last Tools is one of them, but this might be a possibility for us. It's easier to operate, a little bit more user-friendly if it can handle those large data sets, and that's the question that we have. But other than that, that's about it for my presentation. I hope that was useful to people, but I'm more than happy to answer questions.
Okay, thanks, William. We have 4 questions. The first one is from Kent Boots. Can measurements be taken by the investigator in the viewer?
Yes, they can, and they can be taken on the tablet in the field. So one of the things we did during that validation study was we just did a quick measurement from April tag to April tag in the cloud, on the tablet, on scene, while we were doing the validation. So you can do it in Phi3D, which is the tablet software that runs the operation, or you can do it in .3D after the fact, like we just looked.
Okay. The next one is from Todd Davis. When emailing the scans to a client, what format is the final, and how would they view it? Do they need certain software?
The software they need is .3D, which is freely distributed as a viewer. Anybody who has a scanner can distribute that software freely. They're not going to get, your end user is not going to get a fully licensed version unless you've paid for the license or they've paid for the license, but they can view your .dp native .product scans in this .3D viewer, and that would be how that's done. The installation is pretty simple, and like I mentioned, it can be viewed across a pretty wide array of platforms as long as it's Android or PC. There's not an Apple version yet.
Okay, the next question is from Dennis Payne. It says, what are the problems with outdoor use? I've seen a lot of problems when work is done in sunlight.
Yes, and that's going to be a factor with any infrared source. I think the only infrared scanner I have seen that operates quote-unquote well in full sunlight is Mantis, and that's an entirely different price point than what we're talking about. So full sunlight can be an issue for this scanner. We've done some testing, and we want to do some more testing in shielded sunlight, so in shade or in less intense sunlight areas. We want to do some validation there, but that's not currently part of our workflow. I have not seen a big problem with shielded areas on a sunny day so far, but we're not finished with that study, and I really don't want to comment any further on it yet until I've got some hard numbers.
No problem. I said there was 4. There's more than 4 there. They're coming in now.
That's okay.
The next one is, can you explain the 10-minute limitation on capture with the DPI-8? That's from Jared Carter.
Sure thing, Jared. I think the issue there is related to frame-to-frame drift. The longer you capture with this device, the more likely it is for your point cloud to drift out of calibration or out of integration. And that's a feature that is analogous to even tripod scanners, which are not tied down to survey control. If you push them out to, a half mile of distance covered, across several different scans, that point cloud will drift in registration unless you've tied it down to survey control. Same kind of issue with frame-to-frame matching in DotProduct. Each individual video frame that's captured there is a point cloud in and of itself. And as you move from point cloud to point cloud to point cloud, image to image to image, the likelihood of that drift increases. Now you can mitigate that through the use of this AccuScale bar or through the scale bar targeting with the checkerboard targets that you saw in the example that I gave. And I think it mitigates it pretty well, as you saw from the measurements that we made on that vehicle. That they're pretty accurate, and it does a good job. Even though we're not using it in 3 dimensions, we're only using it in 1 dimension. It calibrated that cloud down to be pretty accurate.
Agreed. Okay. The next one is from Kent Boots again. What is your agency using to prepare 2D diagrams, and what is the workflow from DotProduct software? So what else do you use?
Okay, so our workflow is an IntelliCAD product. It's IMS Map 360. Previously it was microsurvey map scenes, but they were acquired by Leica recently. That's our 2D deliverable, and I understand a lot of agencies and a lot of jurisdictions have to still produce 2D diagrams for court purposes or for reports. We're one of them, so I don't see that going away anytime soon. Our workflow for DotProduct to 2D is going to be import into Cyclone, conversion to a PTS point cloud, and then import into IMS Map 360 to produce a 2D diagram.
Okay, they keep coming. Okay, we've got another question from Jason Warren here. Can the registration report be embedded into the properties of the final scan data deliverable?
I am not aware of registration reporting in DotProduct, and that's an excellent question. It's something that we get from Cyclone. When we register DotProduct scans with Cyclone, we get a registration report that shows us the average error, and it is embedded in the metadata of the Cyclone file, the IMP file in Cyclone. So we can always refer back to that. But internally, as far as Phi3D goes and DotProduct goes, I think hopefully maybe you could unmute Chris Ahern and he could answer that question. I'm curious myself.
I don't know if I can.
I'll take care of that.
Okay. You can do an arena for here, of course.
Chris, are you on?
Yeah, can you guys hear me all right?
Yes.
Yeah, so it is correct. There's no registration internally to the DotProduct scan file. but more so if you're registering it with another data set in Cyclone, then you get that report. But it's not something that we have built into Phi3D right now.
Thanks, Chris.
You got it.
Okay, we have one more at the moment. This is from Jared Carter again. So let's say we want to scan a vehicle exterior. Can you speak to the workflow to do that in a single scan? Or would you do the scans, would you do multiple scans and then tie them together?
Well, it depends on the size of the vehicle and the circumstance, but I think we've pretty well validated. I mean, that's not a small vehicle that we did in a single scan. It's a Jeep Grand Cherokee, pretty good size, and we did interior and exterior, not covering every surface, but I would say 80% of that vehicle is well mapped on the interior in a single scan. So if possible, and as long as I was using DotProduct's recommended best practices of some kind of scale bar calibration technique or some kind of total station mapped known points that were tied into my DotProduct scan, I think you can get pretty accurate stuff in a single scan. Now you might run into issues where you have difficulty getting into a space. Another cool feature in DotProduct is I can pause the scan and I can resume appending on the same scan to crawl into the back seat or to crawl into the cargo bay or something else of that nature. Now if I run out, when I say run out, one limitation of this feature is that because it operates on a tablet, it's reliant upon all the RAM in the tablet, which at this point is 2 gigabytes. Their scans are pretty small in size and data size, so that's a fair amount of data being collected, but you can, and I have, reached the end of it before the end of a scan. What you can do in those instances is you can internally append one data set to another data set, which helps you register it outside Phi3D if that's necessary. But I've had, essentially what it's doing is it's tying the UCS from the original scan to the UCS of the next scan. But I've had good luck getting single scans from vehicles.
And the scan that you showed in that video looked really good, actually. I'm just going to say. Right, we've got one more question. That's from Brian O'Neill. And that is, what file formats can the scanner export to? I heard the native format, but does the native software allow exporting it into other formats?
It does. I'll go back here just so that I'm not forgetting any. And they may be more than this, but we haven't had cause to use them yet. So this instrument will export to PTS, PTX, PLY, PTG, and E57. And that's pretty inclusive. And then a lot of these partners up above will natively import DP, including your company. And one thing I forgot to mention, the video of that large scene was produced with Visys Arena 4D, which was really easy to use and nice to use on that video.
Hey, Jared said thanks for the answer, and Todd said thanks for the answers. There are no more questions on the list right now, so I guess that's a wrap, unless someone else comes in.
All right. Thanks a lot, Mark.
Thank you very much. Thanks, guys.
William, would you mind putting up your email one more time just in case people do have questions that they think of later? And
Sure.
then they can email you if that's all right.
Yep.
And then I want to thank everybody for attending. William, that was terrific information. Mark, thank you so much for being a part of this also. I will put this on the IAFSM.org website probably over the next couple of days. So please feel free to view it at your convenience or share it with anybody who was not able to attend. Thank you so much. And William, do you have anything else you want to add?
No, just thank you for giving me a platform to talk about it. I appreciate it.
Absolutely. And once again, thank you, everyone. And we hope you enjoyed this presentation and look forward to a few more webinars over the next few months. Thank you.
Thank you. Good night.
Bye-bye.
Bye.